Hi everyone. Thank you for registering to this introduction to exploratory data analysis illustrated with XLSTAT. My name is Jean-Paul Maalouf. I'm a statistical consultant at XLSTAT, and I'm very happy to talk to you today. Some of you have already attended the previous webinar on descriptive statistics, so this one comes right after. So there are some elements we are going to use, some elements that have been presented in the first webinar, in the previous webinar, that we are going to talk about once again today. But if you haven't attended the previous webinar, there's no worry. I'll do a small reminder. So I'll try to present things as easily as possible without using mathematical complex formula. I'll try to be as conceptual and intuitive as possible. So you may ask me questions all along the webinar using the chatting window. There's no need to use the raise your hand feature. There's a raise your hand feature, just don't use it. Type your questions within the chatting window, and there will be two times. I'll stop twice to answer your questions. So once at the middle of the webinar and once at the end. The handouts can be downloaded in the handouts section, so you can download the presentation material as well as the data we're going to use. And is there anything else I should say? Yes, the recording of this webinar will be available starting from tomorrow evening. So don't worry, you'll have access to a recording of this webinar. So let's go. I'll start as usual with a plan. First, I will present XLSTAT. Then I will talk about my personal way of categorizing statistical methods before switching to a reminder on some things we've seen in the previous webinar on descriptive statistics. So we talked about variables, individuals, and how we could describe these variables and these individuals. So I'll do a small reminder to do a transition, to make a transition toward the core of the current webinar, today's webinar, which is exploratory data analysis. I'm going to do the transition using a scatter plot colored by group. Then I will start talking about exploratory statistics and data mining. That will be illustrated using two mainstream methods within this family of statistical methods. And those two methods are principal component analysis, or PCA, and agglomerative hierarchical clustering, or AHC. So I will illustrate exploratory data analysis using those two tools. And all the data in this webinar were made up unless otherwise specified. Who are we? XLSTAT is a user-friendly statistical add-on for Microsoft Excel. Many of you have already tried it, and those of you who haven't already, I'll do demonstrations today, so you will see how it looks like. Here's a small historical overview. So the software was born in 1993. The first sale occurred in 1996. Then the Addinsoft company was created in 2000. It's the current company that develops the software. In 2006, our code was split into two languages, so VBA for the interface and C++ for computations. And then in 2015, we generated new kinds of products which are field-oriented, and we had a growing and dynamic team. In 2016, we released two main modules, the XLSTAT version for Excel 365. So it's a version that works online, which is a bit limited today, but that we are currently developing, as well as the free version, the XLSTAT free version, which is a limited version of XLSTAT. It contains, I think, 12 or 13 features, but you can use them without having any XLSTAT license. I told you about a surprise we're going to release probably at the end of 2017 or early 2018. So last webinar I talked about a surprise. Today it's not a surprise anymore. We're going to have an integration with R very soon. In a few months, you'll be able to design your own R procedures within XLSTAT dialog boxes and call these procedures from XLSTAT dialog boxes. So this opens really unlimited possibilities in your analysis. And if you like, you can click here to learn more about this R integration. If you are familiar with R, which is an open source statistics language, if you're familiar with it, we are currently looking for beta testers. So if you are familiar with this, we would be happy to have you among our testers and receive your feedback. In a few numbers, XLSTAT contains more than 200 statistical features. We have more than 100,000 users across the world. We are 22 employees. We have 220,000 visits a month on the website. The software is available in 7 languages, and we have 10,000 downloads of the software per month. Now, how can we divide statistical tools into categories? So we have descriptive tools that help you summarize data using simple statistics or charts. We've already seen those during the previous webinar last week. So the mean, the standard deviation, the box plots, the scatter plots, and so on. Today we're going to explore this section, which is exploratory data analysis. And those methods, those techniques, let you easily extract information from a large data set without necessarily having a precise question to answer. So they give you a big data set with 10 columns, 20 columns, I don't know. And you just dive into this data set using techniques such as PCA to extract information you're not necessarily expecting. Just fish for information. So this will be the main topic of today's webinar. In the upcoming webinar, we'll be able to use techniques that help accept or reject very precise hypotheses, assuming error risks. So statistical tests help answer questions whose answers are yes or no. So with exploration, we don't have a very precise question, whereas in statistical testing, we have precise questions whose answers are yes or no. In statistical modeling, we have an integration of all of these methods. Statistical modeling helps understanding the way a phenomenon evolves according to a set of parameters. We have regression, ANOVA, and COVA in modeling. If you haven't done so already, you may subscribe to upcoming webinars. So on statistical testing, we have a webinar on the 16th of November. Then on statistical modeling on the 30th of November. And on December 7, you have a webinar on ANOVA, which is also part of statistical modeling. So we have 2 webinars on statistical modeling and 1 on statistical testing. So don't hesitate to subscribe. Webinars are free, and you don't need to know XLSTAT or to have an XLSTAT license to attend. So share them also with your colleagues who might be interested. And here you have a recording of the webinar we did last week. You can click here to access the recording. Here's a small reminder of what we saw last week. So some definitions: variables, individuals, descriptive statistics. What's a variable? A variable is an element that can take different values. You have quantitative variables. Those are variables that can be quantified, that can be measured with numbers that you can add or subtract. For example, invoice amount, height, number of likes on Facebook, sugar concentration, and so on. You have qualitative variables. Those are variables that cannot be quantified. They are also named nominal variables or categorical variables. For example, the socio-professional category, the gender, the geographical origin, the genotype, the blood type, and all the possible values that a qualitative variable can take are called the categories or the modalities. So for the socio-professional category, you can have different modalities such as university or corporate and so on. An individual is an elementary statistical unit. It can be described with variables. For example, customers who are described by the invoice amount, or surveyed people who are described by the questions they answered. So each question is a variable actually, and each surveyed person who answered this question is an individual. You have patients or laboratory mice who are part of different genotypes or who have different heights, and so on. So the data set we are going to concentrate on today, at least for PCA, is this very famous data set we used last week. Those are clients from an online shoe selling platform. So you have clients in rows. Those are individuals. And those clients are described by several variables in columns. So you have qualitative variables such as origin or gender or preferred brand, and quantitative variables such as height, shoe size, weight, invoice amount, and I think there are other variables also. So in most cases, data sets are organized this way for data analysis. You have individuals in rows and variables in columns. I'm going to show you a small reminder of what we used to describe single variables and pairs of variables last week. So those commonly used tools were illustrated last week. So for one qualitative variable, we use flat sorting, mode, pie charts, or bar charts. For the link between two qualitative variables, we used cross-tabulation or contingency tables. For the link between two quantitative variables, we used the scatter plot. And we investigated one particular case, which is this one. The link between three variables, two quantitative and one qualitative. This was the end of last week's webinar. We concluded the webinar with this case, which is very interesting and which will allow us to do the transition toward exploratory data analysis. So we use the scatter plot with points colored according to the categories of the qualitative of one qualitative variable. So I will show this last plot we saw last week. There it is. You have invoice amount on the y-axis according to time spent on the website on the x-axis. And then all the dots are your different clients, the clients from the database. Now, as you can see, we have colored the points according to the origin, Earth, Mars, and Pluto. Here we have a representation of three variables, basically, two quantitative and one qualitative. So based on this chart, we were able to extract many interesting information, many statements. Invoice amount decreases with time spent on the website. Plutonians spend more money on the website compared to the others. We can also say that Plutonians spend less time than the others on the website. And Martians and humans form a relatively homogeneous group. They are all mixed up around here. And there are many other things we can say out of this chart. So we are basically exploring a data set using one simple chart. We are already doing some exploration. We're saying statements like this that you can still say many more during hours without having a precise question in our head. Imagine now having the same kind of reasoning on a higher number of variables. So now it's time for exploratory statistics or exploratory data analysis. Imagine you want to summarize all the information carried by those four variables. So some of you could say that we could use a 3D scatter plot to illustrate the information that is carried by three variables, height, shoe size, and weight. But what if we had 10 variables or 15 variables or 4 variables? So the human eye cannot see in 4 dimensions. There are techniques such as PCA that will help us summarize the information carried by many columns on very simple charts. And that's what we're going to see right away. So here are a few words on exploratory data analysis. I want to easily extract information from a large data set without necessarily having a precise question to answer. Here are a few words. So a definition of exploratory statistics. Those techniques help us look for information in a multivariables data set or multi-column data set without having very precise expectations. So exploratory tools are part of what we call data mining. Among the main things that you can do using exploratory data analysis is first concentrate the information of big data set in a few dimensions. So reduce the information from a data set with 10 columns to a data set with 2 or 3 columns, which will be easier, far easier to investigate. For example, principal component analysis, correspondence analysis, or factor analysis, or multiple factor analysis, and so on. The second big thing you can do is classification, also called clustering or segmentation. So this set of techniques allow you to split your data into sets of similar individuals, into groups, subgroups of similar cases or observations or individuals or customers. For example, we have the agglomerative hierarchical clustering and k-means clustering. So today we'll focus on PCA from this first thing you can do, and on agglomerative hierarchical clustering from this second set of statistical tools. Let's start with PCA and a very conceptual introduction to this technique. PCA will help us to investigate the relationships among the variables we're investigating, the proximity among the individuals or among the customers in the case of our data set, as well as how individuals relate to variables. So we'll see the relationships between variables, the relationships between individuals, and the relationships between individuals and variables. Here's how it works very conceptually. I won't enter into the details of mathematical computations. This is just a very conceptual approach. So we'll start with the original data set. There it is, our 4-column original data set with height, shoe size, weight, and time spent on site. What I presented in green here is the amount of information that is potentially carried inside this data set. The information is homogeneously spread among the variables, so there's no reason for me to think that there's more information here than here. So I assume that there's potential interesting information in the whole data set. Now what PCA will do is that it will build a new data set, a new artificial data set that will concentrate the information in a few columns. If you look at these numbers, you won't understand what they mean, but actually they don't really mean a lot technically. So they don't mean shoe size, they don't indicate any physical variable actually. So this is not shoe size or weight or anything. So PCA will build a new synthetic data set with a number of column equivalent to the number of column of the initial data set. So here we had 4 columns. We have a synthetic data set built by PCA with 4 columns as well. The difference is that in the initial data set, the information is homogeneously spread everywhere, whereas the PCA will concentrate information, the interesting information, on a few dimensions, on the first dimensions. Here, as you can see, the information is more concentrated on column 1 and column 2. Those columns are called the dimensions of PCA, the PCA dimensions. A dimension is also called axis or factor in PCA jargon. So each synthetic column is called a dimension or an axis or a factor. The information, this abstract concept of information, is also called the variability, and it's also called the inertia. So this is the most technical term. The information is called inertia. So it's spread in the whole data set, in the initial data set, but it's concentrated on a few dimensions in PCA. So this is why we call PCA a dimensionality reduction technique, because we are reducing the number of dimensions, or at least the number of consistent dimensions from the original data set. So how can I set up a PCA using XLSTAT? So I'll go here. This is my data within Excel, and XLSTAT is represented with an additional tab here that includes several menus with different statistical procedures or features you can select inside. And PCA is hidden right here in the Analyzing Data menu. So here I click on PCA, which is the second feature, and I'll select the data on which I want to build my PCA, which is those 4 columns. I'll just reset the dialog box and do things all over again. So here we go. I selected the data within the observations variables table field. I want to add observation labels. I want to add tags to my observations, to my clients, that I recognize them. And here we go. So I click OK. The result appears in a new Excel spreadsheet, but first I need to select the PCA dimensions I want to display within the results, within the charts at least. Here I see that if I select dimensions 1 and 2, or columns, synthetic columns 1 and 2, F1 and F2, I already have a representation of 92% of the information from the initial data set. The 2 first dimensions of my PCA are very strong. They already carry a huge amount of the information. So I don't really need to investigate further. I don't need to check dimension 3 because it's becoming very poor. But in some cases, if dimensions 1 and 2 don't carry enough information or inertia to your eyes, it's also interesting to investigate also dimension 3 or 4 or more. So here, as soon as I'm ready, I click on Done, and the results appear right here. So first I'm going to show you this table, which is quite interesting. Here I have the eigenvalues. We have one eigenvalue associated to each dimension, each PCA dimension. An eigenvalue is the amount of inertia carried by each axis or dimension. Here I see that F1 carries 2.544 inertia. This corresponds to 64% of the total inertia. Then F2 carries 28%. So if we sum up the two, we get 92%. Then I will focus on 2 very important charts in PCA, which is the correlation circle or the variables chart and the observations chart. So I'm going to comment on this using my PowerPoint presentation. You have a link to the PCA tutorial, to the XLSTAT PCA tutorial here. Just if you want to go further in your analysis, just click here. And you also have videos on how to perform PCA in XLSTAT. So here's the correlation circle, the first important chart we want to comment on. The horizontal axis is dimension 1 from PCA, which carries 64% of the inertia. And the vertical axis is dimension 2. And the red vectors, the red lines, correspond to the variables we are investigating. So time spent on site, shoe size, weight, and height. How can I interpret this? Here we're going to interpret the relationships between variables. Things are interpreted in terms of angles. Narrow angles or acute angles depict positively linked variables. So weight and height are super positively linked. Right angles, such as weight versus shoe size, depict uncorrelated variables. So there's no link between shoe size and weight. So if weight increases, shoe size doesn't really move. Wide angles or obtuse angles depict negatively linked variables such as weight versus time spent on website. So when weight increases, time spent on site will decrease. Things are quite straightforward to interpret. So as you can see, we are extracting a lot of information only from this chart on the relationships between variables. Now, some of you may ask, what's the meaning of vector length? Why are there variables that are shorter than the others? Vector length is simply the representativeness in the selected plan, the quality of representation of these variables in the selected plan. Here we selected the plan F1 and F2, a chart representing F1 and F2. And the vector length shows you to what extent are your variables well represented on this plan. So here they are all more or less well represented because they are all associated to big vectors, to long vectors. Well, we could have expected this because this plan, so F1 versus F2, holds 92% of the information. So if we had a short variable here, one that reaches here with its vector, we could expect that it's better represented on another dimension, such as dimension F3 or F4, but this is not the case here. Then we're going to add the interpretation of the axes, F1 and F2. Things are also interpreted here in terms of angles. So it's quite straightforward. If we take F1, we see that it's strongly linked to weight height on the right and to time spent on site on the left. So we have high weight and height on the right, on F1, and long time spent on site on the left. Then if we took F2, F2 is strongly related to shoe size. Look, there's a narrow angle between shoe size and axis number 2. We have big shoes on the top and small shoes at the bottom. So starting from here, from this interpretation of the axis, we are going to add the individuals or the customers using the observations chart, which is also part of the XLSTAT report. Here again, in the observations chart, the horizontal axis is F1 and the vertical axis is F2. And we have our observations, our clients, who are projected on this plan. So we're going to take back our interpretation to recall our interpretations of the axis and the links between the variables. To the right, we have the individuals who are linked to a high weight and a high height, an important height, but they spend less time on the website. And here we have individuals who spend more time on the site, but have less important weight and height. So it's very straightforward to interpret. You just take back the interpretation of the axis. So to the right, we have people with high weight and height and low time spent on site. And to the left, we have the opposite. Then let's have a look at this guy, Derek. He has high scores on the second, a high score on the second axis, which means Derek has a very big shoe size, probably, which is the opposite from Sean, who probably has small feet. So we are able to distinguish two bubbles within our data. We have a bubble from made out of clients with big weight and height and low time spent on site, and another bubble who have opposite behavior. So it's very interesting to notice this in our PCA. This can be one of our statements from our exploration of the data. So here's what we may say out of our explorations. So weight increases with height, shoe size is unrelated to weight height, and so on. So Derek has big feet, and there are many other things we can say, other statements we can say, other hypotheses we can say. So this is how we were able to summarize the information carried by 4 or 5 variables to 2 charts, which are very easily interpreted. Now I didn't show you something on PCA. Here, if you check the observations plot, you see that the observations are not colored according to origin. So this is very easily, can be very easily done, actually. If you go back to PCA, so here I have the previous configuration that is always on. You go to charts, to the observations chart, you click on color by group, and here you select origin. You can also add confidence ellipses around each of the origins, and click OK. And here you obtain the observations chart with which is colored, with the observations colored according to the origin they belong to. So here you have 2 links. One link for the PCA tutorial and another one that takes you to a guide online, an online guide that will help you choose an appropriate exploratory data analysis tool. So here, according to your situation and your data description, you have several tools you can click on and apply on in XLSTAT. So here, PCA can only be applied on quantitative data, quantitative variables. We also have methods that can be applied on qualitative variables such as MCA, multiple correspondence analysis, and that works more or less the same way. So you have a dimensionality reduction technique behind that help you interpret things within a couple of charts. Before switching to AHC, I will answer your first set of questions. Is it possible to design 3D plots using 3 main factors or as axes? Yes, of course, you are able to represent observation charts with the 3 dimensions. So you can take F1, F2, and F3 and use XLSTAT 3D plot to represent those charts. I can show you very quickly. Here you have the factor scores on, or the individual scores that help build the observation chart. You can simply select them like this and go to visualizing data, XLSTAT 3D plot, which is an optional module and which helps, as you can imagine, constructing 3-dimensional charts. So here I have my 3 axes and I can investigate things in 3D. Can you explain the difference between correlation and covariance? So one of you have noticed that you have several PCA types here, correlation, covariance, and Spearman. So most commonly we use the correlation PCA. The correlation PCA is based on the correlation matrix. Well, technically, we always recommend using rather the correlation PCA instead of the covariance PCA, because correlation PCA will set all the variables at the same scale prior to computations. If you use covariance PCA, variables with high variability will have a stronger impact on the PCA. Here, for example, as you can see, weight has a stronger variability compared to time spent on site. So if I use the covariance-based PCA, the weight will have a stronger weight in computations, in PCA computations. So it's really advisable to use the correlation PCA instead, unless you really have a very good reason to use the covariance PCA. When should you use covariance instead of correlation? Well, if If you have questionnaires, for example, if your variables are questionnaires that are measured on the same scale, you are able to use the covariance. There's no problem in using the covariance instead of the correlation. For F1 and F2, when is it enough for the explanation of variance? Well, this is up to you. It's up to you to choose. There are no rule of thumb for this. So if F1 and F2, if you think that if you have a sum here of a cumulative inertia of say 50%, and if to your eyes it's not enough, you need to investigate more. But there are no rules of thumb. It really depends on your field of expertise. I suggest that you consult your literature in the subject of your field of expertise. Is there a limit number of variables? Well, technically there are not, but the more variables you include, the less inertia will be carried by the first dimensions. The more complicated it will be for the PCA to concentrate information on the first axis. Can you visualize colored individuals also in XLSTAT 3D plots? Yes, definitely. You are able to do this. How can we tell which elements of the data are combined in each factor, F1, F2, etc.? Well, you have small indications on to what extent each data point contribute to building the PCA. Here I just go down here. Yeah, here you have the contribution of the observations in building each PCA dimension. So here, as you can see on the first axis, Victoria has a very strong contribution in building the axis. On the second dimension, it's Sean and Derek. If you can remember, Derek was very high on the second dimension. So the contribution of the observations represent the extent to which each observation contributed to the PCA, whereas the squared cosines reflects the quality of representation of each observation on each axis. So here we can see that the observations in bold are the best represented on axis F1. It's the same for F2 and so on. And on F4 we don't have anyone. So I really apologize. I need to carry on now. Maybe I'll take the remaining questions at the end of the webinar, but we should be moving on now because we only have 20 minutes left. So to do the transition from PCA to AHC, I remind you that it was very easy to detect two clusters of customers, which is quite nice for our marketing campaigns. What if we wanted to cluster our customers, but there wasn't such a nice pattern in our PCA? Here we clearly see that there are two groups, two bubbles of groups. But what if people were a bit more mixed up and we couldn't really split them by hand or visually? Here's where agglomerative hierarchical clustering comes in handy. This family of techniques help clustering or classifying or segmenting observations or individuals into homogeneous groups, also called segments or clusters or classes. I'm going to illustrate agglomerative hierarchical clustering. So those techniques are also called unsupervised machine learning. So those include also the k-means algorithm that I won't comment today. I'll just illustrate things with AHC. So AHC, let us go from here to here. I will use another data set. So we asked many chocolate consumers to what extent are they loyal to brands, or are they sensitive to price, or are they keen on online buying, or to what extent do they prefer bitter chocolate, frozen chocolate, crunchy chocolate, and what's their age? So those are scores from 0 to 10, and the age is the age in years. Those data are also made up, so don't take the conclusions very seriously. So my goal now is to split those consumers into several segments. And I will illustrate AHC, which will help us do this, using two variables. But of course, the concept is generalizable on many more variables. And here again, I'll be very conceptual. I will draw the two variables on a scatter plot in 3 dimensions. So price sensitivity on the y-axis and age on the x-axis. And I will put my consumers on the scatter plot. At the beginning, each consumer or each observation is considered a group. So each red dot is a group. First step of AHC. AHC will look for the two groups that are the closer to one another. And AHC would link these two groups. So those two individuals or groups were the closer to each other. They were linked by the AHC. So now we have subtracted one group. We only have 18 groups left. We started with 19, now we only have 18 groups left. Second step, AHC will do the same. It will look for the two groups that are the closest to one another. So say those two, and they will be linked together. Step 3 also, 4, 5, 6, and on, until we reach only one group. So at each step, the two closest groups are clustered together until we reach one single group right here, and we obtain this very famous structure, which is called the dendrogram. Starting from the dendrogram, we can easily split things by using scissors and a cutting level. So say we take scissors and we just cut the dendrogram here. We obtain our segments or groups or clusters. So individuals inside this bubble look more alike than with those customers. So the segments are now defined, and this can obviously be generalized over more than two variables. Here I only illustrated things with two variables, but of course you can apply an HC with including many more variables. So I'll show you how to execute things in XLSTAT. Here's the chocolate dataset. It's here. AHC is also located under the Analyzing Data menu. And there it is. I click on it. And I'll select my data within this field here, simply like this. And I also give tags to my observations under the row labels field. Then in the options, I'll just deactivate this. I really advise you to activate the center and reduce options, because here again we are letting all the variables be on the same scale so that some variables don't have more weight in the computation of the AHC. So I click OK as soon as I'm ready. I'll scroll down to the dendrogram. There it is. Okay. The interpretation of the dendrogram is quite straightforward. Things should be seen as the distance between individuals or between groups should be seen as the vertical walk you should do to go from one point A to one point B to a point B. So take this individual, Cheryl here, and let her walk until Wilbur, who is here. So the walk is quite short. She only has to go 2 stairs up and then go down to Wilbur. So Cheryl and Wilbur are very close to one another compared to Cheryl and other customers. Whereas if you take the comparison between Cheryl and and Marsha, who is here, Cheryl needs to go many stairs up before going down to Marsha and reach her. I don't remember where she is. So this means that Cheryl is quite far away, really far away from Marsha, and there's a big distance in chocolate consuming behavior between Cheryl and Marsha. This is how things are interpreted in dendrograms. I showed you that it's possible to cut
the dendrogram into several groups. So imagine I want to cut it here, or I want to cut it here, or I want to split my individuals into 4 clusters or into 3 clusters. So if I cut my dendrogram here, I get 3 clusters. So that could be interesting. I would have 3 segments of clients to who to which I can send personalized marketing campaigns. So to cut my AHC, I just need to go back to the feature, and then I go to the Options tab and I choose Truncation. So I'll select a number of class of 3. So let's say I want to generate 3 segments. So I click from 3, I enter from 3 to 3 here, and I click OK. Then at the bottom, I get my truncated dendrogram. Here I have my 3 segments, which can make me take very important decisions in terms of marketing. But now, if we reach this point, there's something a bit frustrating. We don't really know how these segments are described or can be described. It could be interesting to see how we can describe in terms of the different variables, all of these segments. So I'll give you a trick. Now just get down to the bottom of the report, and here you have the membership of each individual to each class. So here Bobby is part of class 1, Tammy is part of class 2, or Frank is part of class 3. And there's another way of representing things. Here, the results per object. Here we can see that Bobby is part of class 1, Shale of class 1, Juan of class 2, Frank of class 3, and on and on. So here I advise you to take this class column. So I select it like this, copy it, and paste it next to your dataset. Starting from here, it will become very easy to describe the different classes in terms of brand loyalty, price sensitivity, online buying, bitter, frozen, crunchy, and age. And how can I simply do this? Well, I remind you what we did last week. Went to describing data, and we used descriptive statistics. So those are quantitative data. So I select them under the quantitative data field. And in the subsamples field, I can select the class. So this field will split all of the variables into the different categories of classes and compute specific statistics for each class and each variable. So I click OK. And I get something that I will comment in my PowerPoint presentation. So here we reached this slide so far. So here we have the statistics related to the first variable and each of the classes. So brand loyalty, we have the median and the mean and the standard deviation. We can see that consumers from clusters 1 and 3 are more loyal to the brands than those from cluster 2. So here they have higher mean and median scores than the middle one. If we took age also, consumers from cluster 2 are younger. So this gives us a very interesting clue that mostly consumers who are young are not that attached to brands. There's another way to describe the segments, and it's called the parallel coordinates plot. I will run it very quickly in XLSTAT. You take visualizing data and parallel coordinates plot. Here we take quantitative data and that you split according to groups. Click OK. And here you go. I will comment it also quickly on my presentation. So I apologize, I went quickly on this one, but you have the instructions in your PDF. And you also have a link to the online tutorial. I will just comment on things here. Here on the x-axis you have the names of the different variables we used to describe the classes or the segments that are represented by different colors.
So segment 2 is represented in blue, segment 3 in green, and segment 1 in red. So if you focus on segment 3 or on group 3, you see that you have older consumers who don't really like frozen chocolate, but who prefer bitter chocolate and who are loyal to brands. Then with cluster 2 in blue, you have younger consumers, see, who prefer frozen chocolate and who are sensitive to prices, here, and care less about brands. So out of this, what can you decide marketing-wise? You can promote branded bitter chocolate to older consumers and promote cheaper chocolates to younger consumers, chocolates that are not really branded. There are many, many things that can be decided out of this kind of representations. So in summary, we already saw descriptive statistics that allowed us to summarize small data sets with 1 to 3 variables using simple statistics or charts. And descriptive statistics helped us generate statements or hypotheses. Exploratory statistics also allowed us to do this, but on wider data sets. So we reached hypotheses and statements using exploratory data analysis. So these hypotheses, we will be able to test them very precisely and specifically using statistical tests that we're going to see in the upcoming webinar. So I hope you'll be here so that we could talk about testing. So this was the webinar on exploration. In summary, exploratory statistics are split into 2 main categories. The dimension reduction techniques such as PCA. So those techniques helped us summarize the information carried by several variables into a few simple charts. And clustering techniques such as HC or K-means that helped us cluster our observations or customers or consumers, and we were able to describe these segments or clusters using simple descriptive statistics or parallel coordinate plots. So here you have a reminder on the guide that I showed you earlier. Don't hesitate to subscribe to the statistical tests webinar coming on November 16. All the tools we saw are available in all XLSTAT solutions except the free edition. You can download a 30-day free trial here and discover our products by clicking here. So when you switch off, as soon as you switch off the webinar platform, you'll be asked to fill in a survey. And I thank you very much for attending. I'll take a couple of questions before we end the webinar. If you observe that height and weight are related on the PCA, should you remove one of the 2 to perform PCA? Well, you are doing explorations, so you are not really obliged to remove them. So PCA already gave you a clue. Those variables are related. Do you want to keep only one of them or to remove both of them? It's up to you. So you are really allowed to do anything you want while exploring. You can also remove individuals, you can remove variables, you can do whatever you want and explore and extract information and mine for data, for information. Can we construct an index using PCA? Some people use PCA scores as indices because PCA scores are a synthetic summary of several variables. We saw in our PCA, in our example, that factor 1 summarizes a lot of information carried by 3 variables: the time spent on site, the height, and the weight. So we can take the scores of this axis as an index from some latent idea or latent construct that we can use in further analysis. Can you show us how to calculate confidence ellipses on the PCA? Yes, of course. I'll go back here on my PCA, go up there, I click on. So confidence ellipses can be configured here in the charts. So you take observations, color by group, and click on confidence ellipses and click on OK. And here you will see each origin is surrounded by one confidence ellipse. On F1 dimension was why is time spent on website high on the left side of the axis when the axis labels are negative. Well, here if you take the time spent on site, according to F1 you have an obtuse angle, a wide angle, which means that when F1 increases, time spent on site decreases. Just interpret things in terms of angles and not in terms of signs and scores within the variables chart at least. Can you put the dendrogram on the top of a heat map? Well, yes, this is available in one of our advanced modules, which is omic data analysis. You can draw heat maps with dendrograms. Would you follow AHC with PCA? Well, I will do things the other way around. So I'll start with I would start with a PCA and then do an AHC. And some people even use PCA scores here to draw AHCs, because if you took only the 2 or 3 first dimensions of PCA and drew a dendrogram out of these dimensions while ignoring the last dimensions, you are really building an AHC on columns that concentrate a lot of information, and you are throwing away columns that are not concentrating them. So many people do this technique. They start with a PCA and then they draw AHCs out of the observation scores of the PCA. Pearson PCA can be used in your example. Well, yes, what we just did was a Pearson PCA. A Pearson PCA is a PCA based on correlations. Well, thank you very much for your attention. I really hope this will be useful to you, and I also hope to talk to you in the webinar on statistical testing. Bye-bye.